All right, in this video, I'm going to be talking about how to calculate normal probabilities and percentiles. And I'm using an example 6.8 from the free online textbook, Introductory Statistics, available via OpenStax. All right, one thing I want to point out before I get started is I'm going to be using Excel as my calculator, okay? And if you go to this link and look at the textbook, they are going to use the TI-83 or TI-84 calculator, and they'll provide step-by-step instructions to how to use that calculator. However, when you go out in the workforce, you're probably not going to carry that calculator with you forever, but most jobs will provide you with Microsoft Office Suite, and you will always have access to Excel. So I prefer teaching how to calculate these guys using Excel. Okay, so let's go ahead and get started by reading through this example. We have final exam scores in a statistics class that are normally distributed with a mean of 63 and a standard deviation of 5. Okay, so if X is the random variable for the final exam scores, then it is distributed. That little squiggly line means distributed, normal, and then the mean is 63 and the standard deviation is 5. Okay. Find the probability that a randomly selected student scores more than 65 on the exam. Okay, so they want us to find the probability that X is more than 65. All right, and I think drawing this out is always a good place to start, especially when you're new to learning this topic. So we have 63 in the center. Why is 63 in the center? Because that's the mean, okay? The mean of this distribution is 63. Remember, in the normal distribution, the mean is always in the center. Okay, then 65 is our observed value. 65 is more than 63, so it's going to be over here to the right of 63. And what we want to know is the probability that X is more than 65. So more than 65 will be further to the right. Okay, all right. When I go into Excel, though, and actually if you go and use your calculator as well, all calculators that calculate normal probabilities, they're always going to calculate cumulative distribution functions, or the cumulative probability. And we always cumulate from the left, okay? So if I accumulate from the left, if I plug it in and I figure out the probability, that X is less than 65, let's see, can I use that information in some way? Well, yeah, right? The total probability under this curve is 1. So this is going to equal 1 minus the green area, okay? So 1 minus the probability that X is less than 65 is the probability that X is more than 65. Okay, so let's go to Excel and calculate this. So I'm going to write equals 1 minus, okay, and then I'm going to write norm.dist, open parentheses, okay, X is 65 right now, the mean is 63, standard deviation is 5, and you're always going to write true for cumulative, right, because we're doing cumulative distribution functions, and then press enter, and there we go. That's the probability. They've given it to us, 0.34, if I were to round it 2 decimal places, 0.34. So this equals 0.34, right? And it makes sense that this little red, this area I've highlighted in red, is about 34% of that distribution, okay? So the probability that a randomly selected student scores more than 65 on their exam is 0.34. In other words, about 34% of them will score more than 65%. All right, moving on to the next example. Now let's find the probability that a randomly selected student scores less than 85. Okay, so once again, I'm going to draw out my distribution. Okay, in the center, I always have the mean. The mean of this distribution is 63. So where is 85? 85 is way over to the right, way over here. It's way more than 63. All right, and we want to find the probability. That a score for the statistics final exam is less than 85. All right, so I want to find basically all of this area. What is this area? All right. So actually, that's a cumulative probability. It's in the area to the left. So this is going to be pretty convenient to calculate in Excel. So let me go back to Excel. And I'm going to type equals norm.dist, open parentheses. Right now, x is 85 because we're trying to find the probability that x is less than 85. The mean is still 63, and the standard deviation is 5. You always type true for cumulative. 0.99999 keeps on going like that. If I were to round that, that's almost 1, right? It's approximately 1. It's not exactly 1, but it's a little bit less than 1. It's almost 1. Why is it almost 1? Because it looks like an 85 is a pretty high score, right, for this distribution. And almost the entire total list of possible other exam scores is less than 85. All right, next let's find the 90th percentile. All right, that's the kth score that 90% of the population is below and 10% of the population is above. Right, so if I were to draw out my distribution, here in the center, I have 63, right? And I don't know what this number here is, right? This is what I would need to figure out. Though I know that 90% of the population is less than whatever this x value is, and 10% is more than whatever that x value is. All right, so there's a way I can do this in Excel. All right, and so I'll type equals norm, instead of norm dist, it'll be norm.inv, norm inverse. All right, the probability, you always do the probability on the left side. So the left side was 0.90. The mean was 63 still, and the standard deviation is 5. Close the parentheses and press enter. 69.4. So this x value is 69.4. All right, so the 90th percentile is 69.4. All right, lastly, let's find the 70th percentile. Okay, so if I were to draw up the distribution, here in the center I have 63, and somewhere over here, some x value where I know that 0.70 is below that number and 0.30 is above. Okay, so again, I'm going to go into Excel to figure out what this number here is, okay, using that norm inverse function. Equals norm.inv, open parentheses, the probability now always to the left. So the probability to the left was 0.7, and the mean is 63, and the standard deviation is 5. Close parentheses, press enter, 65.6. So this x value is 65.6. So 70% of the students, you can expect that 70% of the students will score less than 65.6. The 70th percentile of this distribution is 65.6.